In our sky, there is one star, either Betelgeuse or Antares, a red supergiant star. If you were to place it where the Sun is, it would stretch out to the orbit of Jupiter. It's colossal and truly unstable, on the verge of exploding. Prepare for a grand cosmic event of an unprecedented scale. Betelgeuse, the red giant star on the edge of our solar system, is sending terrifying signals through space. Astronomers have discovered something profoundly disturbing about this immense celestial object using the James Webb Space Telescope. Notable scientist Brian Cox has issued a stark warning. The question that keeps coming up is, are we about to witness a supernova explosion so massive that it will forever change the night sky? The life and death of a massive star. The universe is vast, and stars are born, live, and die in astonishing ways. Recently, one star has captured the attention and concern of both astronomers and the general public. This star is Betelgeuse, a red supergiant in the constellation Orion. It is incredibly large and very old. Its unique reddish hue and fluctuating brightness have intrigued scientists for years, but recent events have intensified interest in this cosmic giant. As we observe Betelgeuse, we may be on the verge of a significant turning point in its history. But what do these changes mean? Are we witnessing the beginning of a cosmic spectacle on an unimaginable scale? The immense size of Betelgeuse. Betelgeuse is a stellar monster, over 1,000 times the size of our Sun. Its vastness is difficult for humans to comprehend. Imagine a star so large that if it replaced our Sun, its surface would extend beyond Mars' orbit, enveloping Mercury, Venus, Earth, and Mars. This enormous size is not just an incredible fact, it also tells us something important about Betelgeuse's life cycle. As a red supergiant, it is nearing the end of its life. It is expanding and cooling in this phase, which occurs after converting hydrogen into helium in its core. The age and evolution of Betelgeuse. Betelgeuse is estimated to be between 8 and 8.5 million years old, young in human terms but ancient for a star of its type. Over millions of years, it has transformed from a hot blue star into the red giant we see today. Now it is in its final stage of life. One fascinating feature of Betelgeuse is its distinct red color. This results from its cooler surface temperature compared to other stars, such as our Sun. While the Sun's surface temperature is about 5,500 Kelvin, Betelgeuse's surface is around 3,500 Kelvin. Cooler temperatures cause it to emit light at wavelengths that make it appear red. Historical records from Roman and Chinese periods indicate that Betelgeuse was yellow about 1,000 years ago. In the 9th century, Arabic astronomers first described it as red. This shift in color over centuries is a significant clue in astrophysics, showing how the star has evolved. The mysterious dimming of Betelgeuse. Another unusual characteristic of Betelgeuse is its fluctuating brightness. It is a semi-regular variable star, meaning its brightness increases and decreases over predictable cycles. Typically, it follows a 425-day cycle, along with a longer cycle lasting several years. However, what truly makes Betelgeuse puzzling is its irregular dimming. Unlike many stars that brighten and fade predictably, Betelgeuse sometimes deviates from this pattern. This suggests complex and poorly understood processes are occurring within its massive structure. In late 2019, astronomers and skywatchers worldwide were shocked when Betelgeuse suddenly dimmed dramatically, a phenomenon now known as the Great Dimming. As one of the brightest stars in the night sky, its sudden fading was unprecedented. By February 2020, it was at its faintest recorded level, losing brightness at a rate of 0.01 magnitudes per day. Even casual observers noticed the change. What caused the Great Dimming? Observing Betelgeuse is challenging because light from the star takes 725 years to reach us. This means that when we look at Betelgeuse today, we are actually seeing it as it was in the year 1300. This time lag makes it difficult to predict and track rapid changes in the star's behavior. The Great Dimming event highlighted how little we know about the vast, mysterious universe. Andrea Dupree, deputy director of the Center for Astrophysics at Harvard and Smithsonian, and her team closely studied Betelgeuse's dramatic changes over 3 years. Using the Hubble Space Telescope, they gain new insights into how variable stars function. Variable stars like Betelgeuse expand and contract, causing fluctuations in brightness. However, during the Great Dimming, something unusual happened. Hubble's ultraviolet-sensitive instruments detected massive amounts of material moving away from the star's surface at speeds of 200,000 miles per hour. Eventually, this hot, dense material traveled millions of miles from Betelgeuse, forming a cloud of dust. This dust cloud blocked the star's light, making it appear dimmer from Earth. Dupree and her team estimated that Betelgeuse lost twice as much mass from its southern hemisphere during this event as it typically would. While all stars lose mass over time, Betelgeuse's sudden dramatic mass loss was extraordinary. Astronomers debated whether this could be a precursor to a supernova explosion. The event raised new questions about Betelgeuse's fate and whether we might witness its spectacular end in our lifetime. Could Betelgeuse go supernova? Betelgeuse is about 725 light-years away. If it were to go supernova, the explosion would be bright enough to be visible even during the day and could cast shadows at night. However, scientists are uncertain when this will happen. It could be tomorrow, or it could take another 100,000 years. For now, astronomers continue to monitor Betelgeuse closely, using advanced telescopes like the James Webb Space Telescope to study its behavior. Whether or not it explodes soon, Betelgeuse remains one of the most fascinating stars in our galaxy, a cosmic giant at the end of its life, keeping scientists and skywatchers on edge. Earth. Betelgeuse adds to the mystery because any explosion like this would be visible from Earth, giving people a rare chance to see a supernova up close. But the question remains, what does this dimming mean for Betelgeuse's future? Is it a sign that a supernova is about to occur, or is it just a one-time event in the star's long and complex life? Several theories have been proposed to explain this rapid change. One popular hypothesis suggested that the dimming was a stage in the process of a supernova explosion. This idea gained traction because many believe Betelgeuse is nearing the end of its life. Another common theory is that dust, possibly from the star itself, is blocking our view. It is well known that red supergiants like Betelgeuse shed material, and some believe this matter could have formed a dust cloud thick enough to obscure our view of the star's light. A third theory focused on changes in the star's photosphere, the visible outer layer, which could significantly impact its apparent brightness. This mystery was eventually solved through various observational techniques and in-depth analysis. Spectroscopic studies revealed that Betelgeuse's effective temperature had decreased, suggesting that the star was dimming due to a massive dark spot on its surface. The fact that Betelgeuse's temperature dropped by at least 170 Kelvin during the dimming event supported this theory, indicating major surface activity. Betelgeuse's future has become one of the most fascinating topics in modern astronomy, with many astronomers eagerly awaiting more data to refine their understanding. The star's unpredictable behavior continues to spark discussions about the nature of stellar death and supernovae. Some astronomers believe Betelgeuse may be on the verge of a dramatic transformation, offering insight into the final stages of a massive star's life. When a supernova occurs, it could temporarily outshine an entire galaxy, making it visible even in daylight. Witnessing such an event in real time would be both thrilling and humbling, providing a cosmic spectacle like no other. If Betelgeuse's explosion happens soon, it could offer valuable insights into the mechanisms behind supernovae. Experts are increasingly turning to complex simulations and models to predict when and how the star's demise will unfold. They are also studying past supernovae to better understand how stars like Betelgeuse behave in their final moments. Although much uncertainty remains, scientists are hopeful that Betelgeuse will reveal crucial details that could help answer fundamental questions about stellar evolution, such as why some stars explode as supernovae while others collapse into black holes. Beyond its dramatic dimming, Betelgeuse's mass loss has given researchers a rare opportunity to study how red supergiants expel material into space. By analyzing the star's outer layers and their evolution, astronomers are gaining new insights into the forces at work inside these massive stars. The rapid ejection of material could provide clues about the physics governing mass loss in all stars. This understanding could help scientists refine their models of stellar winds, which are essential for understanding the broader life cycle of stars in our universe. Additionally, Betelgeuse's behavior serves as a reminder of how much remains to be discovered about the cosmos. Despite advances in technology and our ability to study stars like Betelgeuse with powerful telescopes, many mysteries remain. Each new discovery about this star pushes the boundaries of human knowledge and deepens the enigma of the universe. As Betelgeuse's future unfolds, the field of astronomy will undoubtedly continue to evolve, bringing new questions, theories, and discoveries to the forefront. Ultimately, the Hubble Space Telescope, our cosmic watchdog, helped unravel the mystery behind this strange event. Hubble's observations suggested that Betelgeuse's dimming was likely caused by a massive ejection of hot material into space. This material formed a dust cloud that covered part of the star's surface, reducing the amount of light reaching Earth. It was believed that this dust cloud was composed of extremely hot plasma, ejected from a massive convection cell on the star's surface, which then moved through its atmosphere to the cooler outer layers. As it cooled, it formed dust grains, creating a cloud that blocked light from about a quarter of the star's surface. Hubble's ultraviolet spectroscopic observations, which began in January 2019, were crucial in piecing together the events leading to Betelgeuse's dimming. Months before the dimming, these observations detected signs of dense, hot material moving through the star's atmosphere. Several ground-based telescopes also recorded a decrease in brightness in December 2019, particularly in the southern hemisphere. Initially, this ejected material appeared brighter than the star itself, but as it moved outward and cooled, it turned into a dark cloud, causing the sudden dimming. This massive ejection event has placed Betelgeuse at the center of astronomical research. The star expelled about 400 billion times the amount of material typically released in a standard coronal mass ejection. This loss of material, equivalent to several times the mass of the Moon, was significant for both Betelgeuse and our understanding of stellar processes. But what does such a massive ejection mean for theories about Betelgeuse and supernovae in general? It has had a profound impact on how scientists view the final stages of red supergiants. Previously, it was thought that these stars lose mass at a steady rate before exploding at the end of their lives. However, the scale of this ejection challenges that idea, suggesting a more chaotic and unpredictable end-of-life process. Could Betelgeuse be preparing for its dramatic finale, a supernova explosion within the next few thousand years? Some new studies suggest that such an event could happen sooner than previously thought, perhaps in just a few decades. Another important aspect of the Betelgeuse puzzle is the concept of a bow shock. As this massive star moves through space at around 67,000 miles per hour, it interacts with the surrounding interstellar material, creating a bow shock, similar to the wave formed at the bow of a moving ship. This phenomenon not only reveals the star's current state but also provides insights into how stars evolve over time and how they lose mass. What about the star's past behavior? Observations indicate that after this massive ejection, Betelgeuse's surface cooled and became less dense, meaning the star remains unstable years later. Hydrodynamic models suggest a connection between its convective activity, mass ejection, and the subsequent changes in its pulsation patterns. This ongoing instability raises questions about what is happening inside the star and how it might evolve in the future. Moreover, Betelgeuse's mass loss rate is significantly higher than that of many other stars, indicating that its internal forces are interacting in complex ways. The pulsations contributing to this mass loss are moderated by the continuous loss of energy through shock heating and ejection. These observations suggest that Betelgeuse's life cycle is highly dynamic and not as predictable as previously thought. Given these drastic changes, could Betelgeuse be on the verge of going supernova? The question is crucial to astronomers, but the exact timing remains uncertain. However, this unexpected mass ejection has reignited discussions, making scientists wonder if the end is closer than once believed. Current theories are now attempting to determine what this massive loss of material means for the star's health and future. While astronomers focus on Betelgeuse, another supernova, SN 2023X, has also captured attention. This spectacular explosion occurred in the Pinwheel Galaxy, Messier 101, which is only 21 million light-years away. Discovered in May 2023, SN 2023X is not just another supernova. It is the closest one observed in recent years, offering scientists a unique opportunity to study the end of a star's life. The discovery of SN 2023X was a groundbreaking moment. Amateur astronomer Koichi Itagaki, known for discovering previous supernovae, first spotted the rapidly brightening spot on the edge of Messier 101 using a small 0.35-meter telescope. Once he announced his discovery, the astronomy community quickly mobilized, directing telescopes worldwide, including the Hubble Space Telescope, toward this new explosion. Astronomers are now comparing SN 2023X with other supernovae to better understand how they function and how stars like Betelgeuse evolve. This latest discovery is expected to provide critical insights into the processes driving stellar death and supernova formation.